Okay, let's look at number 4. Follow the curve sketching recipe to graph. So we need to list all these things first. So first thing I'm going to notice about this is not a fraction, which means I don't have any asymptotes in this one. No asymptotes, no holes, because I don't have anything on top and bottom that can cancel because there's no bottom. I don't have any asymptotes because there's nothing that will make the denominator 0. So this one is a much simpler problem. We don't have to think about asymptotes. We don't have to think about holes. And because we don't have to think about either of those, my domain is going to be negative infinity to positive infinity. Because I don't have to stop at an asymptote. I don't have to stop at a hole. So let's go through and do intercepts. Y-intercept is when x equals 0. So I would have 0 times 0 minus 1 times 0 plus 2 squared. Well, that's always going to be 0. So that is my y-intercept. Y-intercepts are always listed as coordinate points. For x-intercepts, this is where I set the entire equation equal to 0. So y equals 0. To do this, I would take each factor and set it equal to 0. So this one, that's already 0. Awesome, let's write it as a point. This one, I get x equals 1, so 1 comma 0, write it as a point. This one, I can square root first, so I get x plus 2 equals 0, so then I get x equals negative 2, comma 0, and that's my point. So those are all my x-intercepts. Now let's do our end behavior. So we're going to have our right end behavior as we go to infinity, and our left end behavior as we go to negative infinity. To figure this out, we need to think of what the greatest term would be here. So this, I would have an x times an x, that minus 1 isn't consequential anymore, times an x squared. That plus 2 wouldn't be consequential anymore. So we can kind of think of it like doing a similar thing we did before. When I'm going to infinity, that minus 1 isn't going to matter. That plus 2 isn't going to matter. So then I would have x times x times x squared, which would be an x to the 4th. And I don't have anything in the denominator. So now I can just imagine x to the 4th. As I go to infinity positive numbers, if I plug positive numbers to the 4th power, they're going to be positive. 1 trillion to the 4th power is a really big positive number. If I plug in negative numbers, negative 1 trillion to the 4th power is also going to be positive. So this one, if I go to my sketch over here, as I go to the right, my graph is going to go up. And then as I go to the left, my graph is going to go up. So those are my end behaviors right there. Let's color code them so we can see them a little bit better. Okay, next I have a y-intercept at 0, 0. Let's color code that one. Make that one red. Now I have some x-intercepts at 0, 0, 1, 0, and negative 2, 0. We'll color code those. Now there's one extra step that I need to do. Because I know these x-intercepts are here. So I can start to sketch my graph. I can start to say, well, if I have to go that way, I have to get to my intercept. And if I have to go that way, I need to get to my intercept. But at this point, we need to know, am I bouncing off of the intercept and going back up? Or am I crossing through the intercept and going down? Those are different things. Now, the shortcut way to know that is to look at the factor. Now I'm going to show you the shortcut way and the long way. So shortcut way, I'm going to look at my -2 factor. So that one is right here. Well, this -2 factor is squared. Anytime you have an even exponent on the factor, that means it's going to bounce. So I know, because this is an even exponent, my graph is going to bounce off of it. Now the long way would be doing a sine line. And we'd plug a number 3 in. So 3 would be a positive. 3 minus 1 would be a positive. And 3 plus 2 would be a positive. Squared would be a positive. That's a sine line. So now I have all positives multiplied together. So that tells me from 2 to the left, everything's going to be positive or above the x-axis. And if I look at my graph, I can see that. 2 to the left, everything is positive or above the x-axis. Now I can do from 2 to 0. -2. Let me fix that. -2 to 0. Let's test the number. Let's say -1. So I plug -1 in here. I have a negative. -1 minus 1 is a negative. I think I did that wrong, didn't I? That's a -2. Ha! Sorry guys, let me go back. Plug -2 in there, that's a negative. -2 minus 1 is a negative. -2 and -3 plus 2. There we go. Okay. That's better. So if I put -3 and plug them in, I should get a negative, negative, positive. Okay, let me try again with this one. Between -2 and 0, I'm going to pick -1. So if I plug a -1 in there, it's negative. -1 minus 1 is a negative. -1 plus 2 is a positive, and then squared is a positive. So a negative times a negative times a positive, that's a positive. So that shows me on -2 I'm going to bounce, because I'm in the positive, the top half, and then I'm in the positive, I stay in the top half. So at -2 I'm in the top half, then from -2 to 0 I'm going to stay in the top half. Now at 0 we enter the same question. Am I going to bounce off or am I going to cross through? Once again, I could do a sine line. I could just look at the power. So this one's 0. So this one would be this x. The exponent on this one is a secret 1, which is an odd exponent, which means I'm going to cross through this point. I can double check that with my sine line. Let's pick a number between 0 and 1. Let's say 0.5. So if I plug 0.5 into my equation, I have 0.5, that's a positive. 0.5 minus 1, that's a negative. 0.5 plus 2 squared, that's a positive. So positive times negative times positive, that's a negative. So everything between 0 and 1 should be negative or below the x-axis. So everything between 0 and 1 is negative or below the x-axis. Now I know this one goes up is positive because I have to end at my end behavior. But once again, I can check with my sine line. Let's plug a number greater than 1 in. Let's say 2. So I plug 2 in. 2 is a positive. 2 minus 1 is a positive. 2 plus 2 squared is a positive. Multiply those all together, I get a positive or above the x-axis, so I double checked it. I'm good. So that is actually my sketch of my graph. I'm done. It's sketched. For now, you don't need to worry about how high these maximums and minimums go. We'll actually talk about that in a chapter or two. We'll come back to it later. This is just a sketch for now. Doesn't need to be perfect. In the next problem, we'll try number 5 again, and we'll talk about, do another example of sine lines or using even and odd exponents.